Imagine a patient whose brain has been, well, entirely destroyed by end-stage dementia.
Right. It's a tragic reality for so many families.
Yeah, and they haven't recognized their own children in years.
Yeah.
They can't speak, and the actual physical tissue inside their skull is just irreparably damaged.
The biological hardware is completely broken.
Exactly. But then, just hours before they pass away, they suddenly wake up. They look around the room, recognize their family, and have a perfectly lucid, coherent conversation.
Which, medically and structurally, should be impossible.
Right. The hardware is broken. But it happens. Actually, it happens a lot. And today, we are opening up a stack of sources that takes, well, everything we think we know about the human brain and just turns it completely upside down.
It really does.
We're pulling from cutting-edge neuroscience, quantum biology, philosophy, and these strange medical anomalies to tackle the single biggest mystery of our existence. What exactly is consciousness and, where does it come from?
It really is the ultimate frontier. I mean, for centuries, mainstream science has approached the brain with one very specific assumption. But the sources we are unpacking today force us to step back and look at the whole board.
Yeah, we have to look at the big picture.
Right. And if you synthesize the current scientific and philosophical landscape, there are basically three primary models for how the physical brain interacts with human consciousness.
Okay, lay them out for us.
So the first is the generator model. This is the traditional materialist view you learn in school. It assumes that the biological wiring of the brain, like the chemical reactions, the neurons firing, literally creates consciousness from scratch.
So in that framework, you are simply the product of your biological meat. The brain is basically an engine, and consciousness is just the exhaust coming out of the tailpipe.
That's a great way to put it, yeah. Then the second model is what we call the receptacle. This view suggests the brain holds and shapes consciousness, almost the way a glass holds water.
But it doesn't originate the water itself.
Exactly. And then there is the third, which we will spend a lot of time on today, which is the antenna or the filter model.
The antenna model, okay.
Right. This theory proposes that the brain is essentially a biological receiver. It tunes into a universal fundamental field of consciousness, very much like a radio tuning into an invisible broadcast signal.
And so our mission for this deep dive is to guide you, the listener, through the mounting, highly credible evidence that is actively dismantling that traditional generator model.
Because the data is really starting to point elsewhere.
It is, suggesting that your mind, your actual awareness, might extend far beyond the physical boundaries of your skull.
It's a huge paradigm shift.
I am so ready to get into the quantum physics of this. But if we're questioning whether the brain actually makes the mind, let's look at the human element first.
Sure.
Because if the brain generates the mind, then a severely damaged brain should equal a severely damaged mind, always. But you mentioned anomalies earlier. Do we have hard evidence of the mind working when the physical brain is offline or destroyed?
We do, and it points us directly toward that filter theory. Historically, figures like the pioneering psychologist William James in the late 1890s and the philosopher Henri Bergson, they championed this idea.
Oh, really? So this isn't a brand new concept?
Not at all. They suggested the brain's actual evolutionary purpose is to limit or filter a much larger expanse of mind.
Wait, to limit it, why would it do that?
Well, think about it. An infinite universal awareness isn't very helpful if you are just a primate trying to outrun a predator.
Right. You'd be too distracted by the cosmos to notice the tiger.
Exactly. The brain acts as a reducing valve, trickling in just enough consciousness to help us survive in a physical 3D environment.
So the brain is protecting us from being overwhelmed. I like the radio analogy here. If I take a hammer and smash a radio, the music gets distorted and eventually stops.
Right.
But the smashed radio doesn't mean the radio created the music. The broadcast is still in the air. The receiver's just broken. But wait, if the brain is just a receiver, what happens when it shuts down entirely? Shouldn't the signal just vanish?
That brings us back to the phenomenon you described at the very beginning, terminal lucidity. Medical professionals document this regularly. A patient's brain hardware is destroyed by Alzheimer's or massive trauma.
Right.
But as the body begins its final shutdown processes, that damaged biological filter momentarily drops away entirely.
Oh, wow.
And the intact self, that unhindered consciousness, shines through clearly one last time. We see the exact same implication in near-death experiences, or NDEs.
I feel like NDEs are always treated as somewhat anecdotal, though. People seeing tunnels of light. Is there hard data there?
There is incredibly rigorous data. One of the sources we are looking at is a massive study published in the medical journal The Lancet, led by cardiologist Dr. Pim van Lommel.
Okay, The Lancet is a major publication. What did he find?
He specifically studied cardiac arrest patients who had completely flatlined. No heartbeat, zero measurable brain activity on an EEG. Yet these patients reported hyperlucid thoughts, memories, and out-of-body experiences.
That's wild.
Yeah.
With zero brain activity.
Zero. There is a very famous documented case involving a woman named Pam Reynolds. She underwent a highly specialized surgery where the blood was physically drained from her head and her brain was cooled to 16 degrees Celsius.
So she was clinically temporarily dead.
Yes. And yet she was able to accurately describe the specific, unique surgical tools the doctors were using and the exact conversations they were having while her brain was entirely measurably offline.
How does traditional neuroscience explain someone without blood in their brain hearing a conversation?
It struggles to, honestly. Van Lommel's conclusion was that human consciousness simply does not always coincide with brain functioning. It's too restricted of a model.
So if the mind survives the immediate death of the brain, do we have any evidence of it sticking around longer? Like, does that memory survive permanently?
The sources point to the Division of Perceptual Studies at the University of Virginia for that exact question. Dr. Ian Stevenson founded it, and Dr. Jim Tucker leads it now.
Oh, the UVA team. They do fascinating work.
They do. They have spent decades investigating over 2,000 cases of young children, usually between 2 and 6 years old, who possess highly specific, verifiable memories of past lives.
I always wondered about the methodology with things like that, though. Couldn't the parents just be coaching the kids or, I don't know, projecting things onto them?
It's a fair question, but the UVA team actively works to rule out coaching, fraud, and simple coincidence. The details are usually way too obscure for a child to invent.
Give me an example.
Well, there is a case involving a toddler named James Leininger. He was having horrific night terrors about plane crashes.
Yeah.
He told his parents he used to fly a plane off a ship called the Natoma.
A toddler said that.
Yes, and he even named his former wingman Jack Larson. The researchers investigated and found an actual WWII pilot named James Houston Jr. who died exactly the way the toddler described, flying off a carrier called the Natoma Bay.
Wait, really? And the wingman?
His wingman was indeed named Jack Larson.
That is unbelievable.
There's another case involving a 4-year-old named Ryan Hammonds. He remembered over 50 incredibly obscure details about a minor 1940s Hollywood agent named Marty Martin.
A Hollywood agent.
Yeah, these were facts the parents didn't know and couldn't easily look up. They had to go into the archives to verify them.
Okay, so if memory and identity can survive bodily death and apparently attach to a completely new biological receiver years later, where is that information living in the meantime?
That is the million-dollar question.
It strongly suggests the mind isn't locked in the skull, which makes me wonder if consciousness doesn't live exclusively in the brain, where else could it be hiding? Are we seeing signs of this signal anywhere else in human biology?
We absolutely are. To understand this, we have to look at the groundbreaking work of biologist Michael Levin at Tufts University.
Okay, what does he study?
Levin studies something called bioelectricity, but specifically in non-neural tissue. We are so used to thinking of electrical signals as the exclusive language of the brain and the nervous system.
Right, neurons firing.
But Levin's lab has proven that all the regular cells in your body, skin cells, bone cells, organ cells, they communicate using their own bioelectric fields.
I'm trying to visualize this.
Yeah.
What do you mean by a bioelectric field outside the brain?
Every cell has a tiny electrical charge. Levin discovered that networks of cells use these charges to talk to each other, acting almost like a bioelectric software running on the hardware of your body.
So they're running the body, okay.
Levin's team demonstrated this with something they call Picasso tadpoles. They took frog embryos and genetically scrambled their faces. They put the eyes, the mouth, and the nostrils in completely random, incorrect places, like a Picasso painting.
Under a standard biological model, wouldn't they just grow into terribly mutated frogs? I mean, the genetic code is wrong.
That is exactly what should happen, but it didn't. The tadpole cells communicated bioelectrically, recognized that the anatomical architecture was wrong, and actively rearranged their own faces as they grew.
You're kidding.
No. They shifted the eyes and mouth around until they formed perfectly normal frogs. Levin demonstrated that these bioelectric fields actually store architectural memory.
So the cells themselves are making decisions.
Yes, the cells make active decisions and guide physical growth to fix errors, all without a brain telling them what to do.
Okay, let's unpack this. This is what Daniel Dennett and Michael Levin refer to as cognition all the way down, right?
Precisely.
If a cluster of regular cells can make an active decision about where an eye should go, then consciousness isn't this magical switch that only flips on when you build a complex human brain. It's a spectrum. It exists across all biology.
And the implications for medicine alone are staggering. Levin has shown that this non-neural communication plays a huge role in cancer, for instance.
In cancer? How so?
His team can induce metastatic melanoma in normal animals just by altering the bioelectric signals of the cells. No carcinogens, no genetic damage required.
Wait, just by changing the electrical signal?
Yes. They essentially scramble the cells' communication, and the cells decide to stop cooperating with the body and become tumors. Conversely, they can use bioelectric fields to reprogram those cells and normalize existing tumors.
Wow.
So if non-neural networks are constantly sharing information and making decisions, the human brain might not be the creator of consciousness. It might just be a highly specialized, incredibly fast version of a fundamental process existing in all living things.
Okay, I'm tracking with the idea of cells communicating and consciousness being a spectrum. But if we scale that back up to human consciousness, how's my brain actually tuning into this supposed universal field?
That's where we get to the mechanics of it.
Right, because I can't just be an antenna made of wet meat. There has to be an actual physical mechanism doing the tuning, right? What is the dial on the radio?
For that mechanism, we have to travel out of biology and down into the strange world of quantum mechanics.
Oh boy, here we go.
This brings us to a highly controversial yet deeply compelling theory called orchestrated objective reduction, or ORC or R. It was developed back in the 1990s by the Nobel laureate physicist Sir Roger Penrose and an anesthesiologist named Dr. Stuart Hameroff.
Wait, a physicist and an anesthesiologist teaming up to solve consciousness. That feels so random, but I guess you need someone who understands the universe and someone who puts people to sleep for a living.
It sounds like a joke setup, but their combined expertise is exactly why the theory works. Penrose approached the problem purely mathematically. He looked at Kurt Gödel's incompleteness theorem.
Okay, I'm going to need you to explain Gödel's theorem to me like I'm 5 years old.
Think of any standard computer program. It runs on a rigid set of rules and algorithms. Gödel mathematically proved that any rigid, rule-based system will eventually hit a wall.
Meaning what?
Meaning it will encounter mathematical truths that it simply cannot prove from inside its own code. But a human mathematician can look at that same problem, intuitively step outside the rules, and see that the truth is obvious.
So we can see the forest for the trees, but a computer can only see the bark.
Exactly. Because humans can step outside the code, Penrose deduced that whatever is happening in our brains to produce understanding cannot be a standard computable algorithm.
So we aren't just advanced biological calculators.
Right. And in physics, the main candidate for a non-computable, unpredictable process is the collapse of the quantum wave function.
Which is what, exactly?
This is the idea that microscopic particles exist in a cloud of overlapping possibilities, a superposition, until something causes them to collapse into one definite state.
Okay, I follow.
Penrose proposed a new form of collapse called objective reduction. He theorized that when a superposition reaches a certain threshold of mass, the fundamental geometry of space-time gravity itself forces it to collapse. And each of these little quantum collapses creates a tiny flicker of conscious awareness.
But Penrose is a theoretical physicist. He didn't know where in the messy human brain this delicate quantum physics could actually be happening. That's where the anesthesiologist comes in.
This is where Dr. Stuart Hameroff steps in to fill the gap. Hameroff brought the biological mechanism to the table, microtubules.
Microtubules, what are those?
They are tiny, hollow cylinders made of tubulin proteins. Think of them like microscopic Lego blocks that link together to form the structural scaffolding inside all of your cells, especially inside your neurons.
Okay, so structural scaffolding.
Yeah. And Hameroff noticed that general anesthetics, the very drugs that erase consciousness, seem to directly bind to these microtubules. He proposed that the hollow insides of these microtubule tubes could shield and host the delicate quantum superpositions Penrose was talking about.
So what does this all mean? Instead of thinking of the brain as a computer wiring together bits of data, Penrose and Hameroff are saying it's more like a vast orchestra.
Yes.
The microtubules inside our neurons are the instruments. They are tuning up, vibrating in these multiple quantum states at once until they reach a crescendo. Then gravity forces them to collapse into a single unified chord. That chord is a moment of conscious awareness.
Orchestrated objective reduction. It's a beautiful way to visualize it.
But wait, I have to push back here. Isn't the brain way too warm, wet, and noisy for quantum physics? I read the physicist Max Tegmark's critiques on this.
Yes, Tegmark's critique is famous.
I thought quantum computers had to be kept at absolute zero in supercooled vacuums. Otherwise, the environment disrupts the quantum state instantly. Didn't Tegmark calculate that quantum states in the brain would collapse in femtoseconds? Way too fast to affect a neuron.
You're right. Tegmark's critique was the dominant view for decades. The brain was considered too messy. But laboratory pushback over the last 5 years has calmly begun dismantling that assumption.
Really? How?
We are seeing groundbreaking experiments proving that biology has evolved to protect these quantum effects. For example, at Princeton University, researchers Gregory Scholes and Eric Kalra ran an experiment where they applied a fluorescent dye to microtubules and hit them with light.
And what happened?
They observed the energy diffusing through the microtubules 5 times further than classical physics allowed. The only explanation was a quantum resonance acting like a wave.
That's incredible.
And crucially, when they added general anesthetics to the microtubules, that quantum diffusion was significantly dampened.
Wow. So the anesthetic that puts you to sleep is literally disrupting a quantum energy transfer.
And it goes further. A 2024 study led by Jack Tyszyski's team confirmed a phenomenon called ultraviolet superradiance within the tryptophan networks inside these microtubules.
Okay, you're throwing a lot of big words at me. Explain tryptophan networks and superradiance for us. What does that actually look like?
Sure. Tryptophan is an amino acid inside the microtubule. When grouped together into networks, they act almost like biological fiber optic cables.
Okay, fiber optics in the brain.
Right. And superradiance is a collective quantum effect where these molecules trap and share ultraviolet light in a synchronized, incredibly powerful burst. Biology is essentially using quantum optics.
That sounds like science fiction.
It does. Now, to remain completely impartial, we do have to note that this is a highly debated space. Critics argue that endogenous ferritin, which is a naturally occurring iron protein in the body, might quench this superradiance before it can do anything useful.
So it's still being debated.
It is, but the sheer fact that quantum optical effects are being measured in brain structures at all is a massive paradigm shift.
Are there any experiments linking this back to how anesthetics actually turn off the mind? Because that seems like the crucial link.
Yes, and this is perhaps the smoking gun. A researcher named Nao Li in China tested xenon gas, which is a known anesthetic, on mice.
Xenon gas, okay.
Xenon comes in different isotopes. Now, isotopes are chemically identical. The only difference is the number of neutrons in the atom's core.
Right, chemistry 101.
So, biologically and chemically, 2 isotopes should have the exact same anesthetic effect. But they found that xenon isotopes with an odd number of neutrons were 20% weaker in putting the mice to sleep.
Wait, why does an odd number of neutrons matter?
Because an odd number of neutrons gives the atom a quantum property called spin, making it act like a tiny magnet.
Oh.
The fact that quantum spin changed the potency of the drug implies that the anesthetic is interacting with the brain on a quantum mechanical level, not just a classical chemical one.
That is wild.
It gets better. Researchers like Hartmut Nevin at Google and Kenneth Kosick are literally trying to replicate these effects using brain organoids.
Organoids, like lab-grown brains.
Exactly. These are lab-grown mini-brains about the size of a lentil that develop spontaneous brain waves. They are applying anesthetics to these organoids to watch the quantum disruptions happen in real time.
That is fascinating.
When you synthesize all this data, a compelling picture emerges. If anesthetics turn off consciousness, and anesthetics disrupt quantum states in microtubules, we may have literally found the physical dial on the brain's antenna.
Here's where it gets really interesting. If our brains are operating via quantum mechanics, if we are tuning into a universal field through quantum superpositions inside our cells, how does that connect us to the rest of the universe?
It connects us through entanglement. In 2022, the Nobel Prize in Physics was awarded to Elaine Aspect, John Clauser, and Anton Zeilinger for proving that quantum entanglement is an absolute reality.
This is the stuff Einstein hated, right?
Yes. He called it spooky action at a distance. It's the phenomena where 2 particles become inextricably linked, so that whatever happens to one instantly affects the other, even if they are light years apart.
And we've proven this.
Beyond a doubt. Zeilinger's team used a satellite called MUSHIS to beam entangled photons across 1,000 kilometers of space, proving that this connection is instantaneous and ignores physical distance.
So if entanglement is a proven law of physics, and our brains are quantum receivers, what does that mean for our everyday reality?
It brings this cutting-edge physics into direct dialogue with philosophy. The sources point to frameworks like the physicist David Bohm's holographic paradigm.
How does that work?
Bohm theorized a deeper level of reality where everything is unbroken and undivided. If you shatter a normal photograph, you just have pieces of a picture. But if you shatter a holographic plate, every single tiny shard still contains the entire image of the whole.
So the part contains the whole.
Exactly. Analogously, your brain might contain the information of the entire universe. This also aligns with cognitive scientist Donald Hoffman's theory. He argues that the physical 3D reality we see is just a user interface.
Like on a computer screen.
Right. The space, the time, the physical objects, they're just desktop icons hiding a much deeper underlying network of conscious agents.
Think about what that means for you listening to this right now. If entanglement is real, and your brain possesses these quantum properties, then the boundaries of you don't actually stop at your skull.
They really don't.
You aren't just an isolated machine observing a cold, dead universe. You could literally be entangled with the fundamental fabric of the cosmos.
Which is why we need to ground this deep dive in practical implications. Why should you care about any of this?
All right, what's the takeaway here?
Because viewing the brain as a receptacle or an antenna fundamentally changes our ethical responsibilities. If consciousness isn't a byproduct of human biology, but a universal field that complex structures tune into, it promotes a profound sense of interconnectedness.
It changes how we see everything.
It reshapes how we view animal life, recognizing that they too are tuning into this exact same field. It changes how we approach mental health. Perhaps we are treating a tuning issue, static on the radio, rather than a broken machine.
That's a beautiful way to look at it.
And it alters the grieving process, offering a scientifically grounded framework for the idea that the signal of a loved one persists long after the physical receiver is gone.
It is a total paradigm shift. Thank you for joining us on this journey today. We've gone from smashed radios and terminal lucidity to quantum superradiance and the holographic universe.
It's been quite a ride.
It has. But I want to leave you with one final provocative thought to mull over on your own. If consciousness isn't magically generated by biological meat, if it is a fundamental field in the universe that highly complex structures tune into, what happens when we finally build an artificial intelligence with a highly complex quantum-level architecture?
That is the ultimate question.
Will it just simulate human thought, or will that machine suddenly tune into that exact same universal field and truly, genuinely wake up? When we started, we talked about looking at an X-ray of a broken arm, wanting that clean, jagged line of certainty. But maybe consciousness was never the bone. Maybe all along, consciousness has been the light of the X-ray itself, invisible, pervasive, and revealing everything it touches. Keep diving deep.